Last year, the USS Abraham Lincoln steamed toward the Persian Gulf, carrying America's most powerful naval air wing.
But here is what the Pentagon is not telling you about the future of global naval aircraft survival. The Chief of Naval Operations admitted that in 10 years, those F-18 Super Hornets might not survive.
Success in modern conflict depends on planning coordination and the ability to adapt when the map changes.
Supremacy World War II is a strategy game built around research and deploying tanks, submarines, and powerful jets.
New players will receive an elite railgun valued at $40 completely for free through my link.
Iran's air defenses are evolving so fast that current carrier jets could soon become dangerous electronic death traps.
The Navy is gambling $900 million on a fighter so advanced it outclasses the F-35.
During Operation Midnight Hammer, fourth-generation non-stealth aircraft were risked against Iranian systems in very dangerous missions.
The Navy's F-35C has limited numbers and limited range, leaving the F-18 as workhorse.
Designed in the 90s, the Super Hornet was never meant to penetrate air defenses of the late 2030s.
Admiral Cottle stated that in 10 years, today's F-18 capabilities might not be enough for missions.
The fundamental problem is the lowering cost of entry into the high-end air defense technology game.
Russia and China are sharing advanced technology, meaning anti-American actors now have access to sophisticated systems.
The Houthis acquired long-range missiles and drones, sophisticated enough to target Western warships in the Red Sea.
Radar systems are getting more sensitive, and electronic warfare is becoming more sophisticated with every passing year. The F-18 is a phenomenal aircraft, but its radar cross-section was never optimized for modern systems.
Its range requires carriers to sail dangerously close to enemy shores, making it a knife against vests.
The F/A-XX will bring stealth beyond anything the Navy has ever flown in its entire history.
Enemy systems might not even know it is there until missiles are already in the air today.
FAXX will have 25% more range than current carrier aircraft, expanding its total combat radius.
The MQ-25 Stingray will provide clandestine refueling, topping off fighters in ways adversaries cannot detect.
The FAXX will have electronic warfare built into its DNA, replacing the Growler for blinding enemy air defenses.
The aircraft will control multiple collaborative combat aircraft, providing additional sensors and targets for the enemy missiles.
Adversaries see a swarm and cannot tell which target is the manned aircraft while the fighter strikes.
The Air Force prioritized their own fighter, the F.
Congress added nearly $900 million for FAXX, with a mandate to build this thing faster.
Even with more funding, the FXX probably will not reach squadrons until the middle of 2030.
The Navy requires no chinks in the armor while maintaining the current F-18 fleet for bridge.
If carrier-based jets cannot penetrate air defenses, and the aircraft carrier becomes a floating target instead of fortress,
smash that subscribe button and hit the notification bell to stay updated on the latest naval developments.
Drop a comment below and letting us know if you think the Navy is cutting it too close.
Stay vigilant, fair winds and following seas, as we look toward the next generation of American power. Command real-time battles in Supremacy World War III, and get your exclusive elite railgun now.
Manufacturing precision components for the Navy requires rigorous quality control and advanced robotics on the production line.
The circuit board must withstand extreme thermal stress, during combat equipments.
Testing the phased array radar involves complex signal simulations to verify its tracking range and absolute accuracy. The chassis of the mobile launcher is built from high-strength steel to support massive weight requirements.
Forging the armor plating for command trailers protects the crew from shrapnel and nearby rocket impact today.
Applying specialized anti-corrosion coatings to the missile canisters ensures they remain operational in various harsh conditions. Designing directional antennas for electronic warfare requires complex modeling of electromagnetic fields to achieve the desired effect. Inspecting jet engine components for the Navy reveals any microscopic fractures that could cause engine failure today.
Managing massive quantities of jet fuel requires specialized storage and transport systems to maintain purity for flights.
Integrating advanced avionics into modern aircraft requires a sterile environment to prevent any dust from damaging parts.
Logistics teams work around the clock to move critical spare parts to the field for rapid repairs.
Wind tunnel testing helps engineers optimize the missile control surfaces for high-speed maneuvers during the flight.
Calibrating thermal sensors ensures that reconnaissance systems can accurately detect heat signatures against the cold sky backdrop.
Manufacturing the complex electrical harnesses for the Navy involve miles of high-grade copper wiring for data.
Automated material handling systems increase efficiency in the defense supply chain by reducing manual labor for parts.
Testing the hydraulic systems ensures that the radar mast can deploy and retract quickly under high pressure.
Producing durable flight deck gear helps protect personnel from the harsh environmental conditions on the carrier deck.
Providing mobile power to the Navy requires large industrial generators that must operate reliably in all weather.
The scale of modern defense production involves thousands of workers and billions of dollars in specialized technology.
Maintaining a ready supply of interceptors is essential for protecting strategic assets from any future airstrikes.
Industrial cooling systems prevent server overheating while processing vast amounts of global tactical data for the Navy.
Satellite surveillance provides the military with real-time intelligence from space, helping detect any surface naval movement. Assembling miniature drones requires a clean environment and high-precision robotics to ensure reliability in the field.
Automated laser cutters provide high accuracy when producing stealth components for the next generation of military jets.
Underwater maintenance using robotics allows for the repair of naval vessels without the need for dry docking.
Shredding electronic components ensures that sensitive military information remains secure and cannot be recovered by the enemy.
3D printing allows for the rapid production of complex metal parts, reducing wait times for naval repairs. Logistics teams manage the supply of medical kits to ensure that sailors have access to healthcare everywhere.
Directed energy weapons are calibrated to disable enemy electronics with high precision and low collateral damage today.
High-capacity filtration systems provide clean water for cooling and personnel use aboard the massive aircraft carriers.
Robotic welding cells increase the speed and safety of ship hull integration in the modern naval shipyard.
Virtual reality design allows engineers to detect problems before a single piece of metal is ever cut.
Machining propeller blades to precise specifications reduces underwater noise and improves the speed of naval vessels today.
Advanced fuel research improves the efficiency and range of aircraft during high-speed and high-altitude missions.
Software diagnostics ensure that missile guidance systems are fully operational and updated for the next tactical mission.
Automated guided vehicles move heavy munitions efficiently through warehouses, reducing the risk to the logistics personnel today.
Pressure testing steam systems ensures that carrier propulsion remains reliable during the most demanding of naval maneuvers.
Reinforced crates protect sensitive communication gear during transport to the fleet for immediate tactical combat use today.
Maintaining sensors on the ship's mast is essential for detecting enemy threats in the dark ocean environment. High-pressure water jet cutting provides a cold cut that preserves the structural integrity of specialized naval.
Miles of copper piping are required for the cooling and fuel systems of a modern naval vessel.
Automated laser inspection ensures that every jet engine meets the strict tolerances required for high-speed flight.
Rolling aluminum into thin sheets provides the lightweight material needed for the skins of the modern aircraft. Managing the massive electrical grid of an aircraft carrier requires constant monitoring to prevent power system failure.
Regular hull inspections are necessary to ensure that warships remain watertight and safe during the long missions.
Monitoring signal waveforms ensures that radar systems provide clean and accurate data to the ship's command center.
Moving massive components like propellers requires specialized cranes and heavy-duty crates to prevent damage during transport.
Testing catapult launch systems on the ground ensures they are ready for the intense operations at sea.
Regular maintenance of weapon systems ensures that missiles can be launched reliably during a high-intensity confrontation.
Laser alignment of radar systems is critical for tracking targets with pinpoint accuracy at extreme nautical ranges. Calibrating laser designators ensures that precision-guided weapons hit their targets with the highest possible success rate.
Programming industrial robots for delicate maintenance tasks reduces the human error in the repair of flight computers.
Maintaining the tension of arresting gear is essential for the safe recovery of aircraft on carrier decks. Fuel distribution networks are monitored to ensure that aircraft are refueled quickly for the next tactical mission. Cleaning high-precision lenses in a sterile environment prevents any dust from obscuring surveillance footage from drones.
The installation of sonar domes is a delicate task that is crucial for the anti-submarine warfare.
Sensors must be kept clean to ensure that the ship's radar provide a clear picture of sea.
Separating sediment from fuel ensures that ship engines run smoothly during the long missions across the ocean.
Industrial production of ship components supports the global might of the world's most powerful and modern navy. Headset testing ensures clear communication between the carrier bridge and pilots during high-stakes naval flight operations.
Specialized coatings protect critical engine parts from the extreme temperatures generated during high-speed jet flight maneuvers.
Simulation training prepares naval aviators for the complex challenges of penetrating modern integrated air defense systems today.